Hello, we are working in Chapter 1, Section 5, Properties of Exponents. And we're just like the other sections that we covered this week. We're skipping example number 1. We're just doing 2 parts of each one. We're just doing 2 concepts in each section, I should have said. In this section, the first one, we're going to talk about negative exponents. What happens if the exponent is negative? So this is my next slide, so let me show you what I mean. All right. So what does 2 to the negative third power mean? What does negative 3/4 to the negative fourth power? Each of these exponents are negative. So what does it mean to have a negative exponent? Well, I know that sometimes what I've seen students in classes is they get a little frustrated with this because we don't really have a good idea what an exponent is. And I'll as I do some explaining here, I'll tell you why I say that, like what students do when they see that. I think a lot of them have an idea that exponent means that you're going to have repeated multiplication. So instead of me writing 5 times 5 times 5 times 5, in my experience, most students figure out that, oh, that means you want to do 5 to the fourth power. Well, where does that 4 come from? Because I've got 1, 2, 3, 4. I've got 4 5s that are being multiplied together. And we explain this, and students nod their head, and it's like, okay, we explained it. That's all there is to it. Then someone will say, well, what does that equal? There's that equal word again. And almost every time someone's going to say, well, that equals 20. Because they know exponents mean multiplying somehow. So they multiply the 5 times the 4. And you're probably thinking, no one does that. Well, just wait. I'll get to it. I'm going to show a pattern here, and I want you to see what's going to happen here, okay? So if I do, and actually I should have written it this way. I'm going to rewrite this. 5 to the fourth power, that's the same as 5 times 5 times 5 times 5, okay? So I say, well, what does 5 to the third power? Well, all right, that's 5 times 5 times 5. Well, this, by the way, I said some people say it's 20. It's not. It's actually 625. This is 125. You say, well, what did you do to go from 625 to 125? Well, if I go this way, I'm dividing by 5. If I go the other way, I'm multiplying by 5. I took this and multiplied by another 5. So if I go the opposite direction, I'm dividing by 5. Okay, keep that in mind. Say, well, what's 5 to the second power? Well, that's 5 times 5. And again, 125 divided by 5 equals 25. 5 times 5 is 25. So then we say, well, what's 5 to the first power? And we kind of mentioned that in the previous video when I was talking about place value, because I used 10 to the first, but I didn't really go into detail with it. 5 to the first power is just 5. And I also mentioned previously about showing things that are hidden. Well, there is a hidden exponent right there. There's a hidden exponent of 1 right on that 2. Every time there's always, like, there's a hidden exponent of 1 right there. Just, we don't write it, but we have to know that it's there. It's one of the things that we have that's hidden. Okay? All right. So pay attention to what we just did. As I go down 625, 125, 25 to 5, as I'm going from the bigger numbers to the smaller numbers, I'm dividing by 5. Going the other direction, I'm multiplying by 5. If I go up, I'll do it that way. I'm going to multiply by 5. But I want to focus on this, dividing by 5. So look at the pattern. 4, 3, 2, 1, what's next? 5 to the 0 power. And if I follow my pattern over here, if I divide by 5, 5 divided by 5 equals 1. And that is where people's heads are going to explode. They want to say 5 to the 0 power should equal 0, right? Well, again, does 5 to the fourth power equal 20? No. So why does 5 to the 0 power equal 0? Because they want to multiply 5 times 0. Anytime I see a 0, the answer's got to be 0, right? Well, no, that's not the case. If I add 0, I don't get 0, unless I start with a 0. So there's a lot of confusion with how do I get a 1 out of here? That's because of what exponents actually mean. 5 to the first power is 5. 5 to the second power is 5 times 5. If I reverse it, instead of multiplying by 5, I'm dividing by 5. And this is actually 5 divided by 5. So the first thing is any non-zero number to the power of 0 equals 1. Now, this is really important that I do that, because 0 to the 0 power at this point is undefined. And the reason why is because you can't divide by 0. That right there is something you're going to talk about in calculus when you get into, sorry, let me bump my paper, get into L'Hopital. L'Hopital's rules. But don't worry about that. That's calculus. Calculus where we talk about important ideas like that. I'm not finished with this over here, though. What if I keep going? 4, 3, 2, 1, 0. What about 5 to the negative 1 power? Well, remember, I'm still dividing by 5, so I get 1 divided by 5. As a decimal, this is 0.2. Now check this out. 5, which is the base I'm using, and 1/5 are reciprocals. But there is a much better way to describe reciprocals, and this is one of my favorite words. They're called multiplicative inverses. And that word right there, multiplicative is fun, but inverses is very important to understanding algebra. You're going to see it in lots of different places. On your graphing calculator, there's going to be a button that says this. It's used in functions. It's used in matrices. But it's not reciprocals when I talk about this. It's inverse functions and matrix inverses. This we'll talk about that. You'll talk about in pre-calc. But the symbol for it goes back to this idea of multiplicative inverses. 5 to the negative 2 power is 1 over 5 squared, or you can say 1 over 5 times 5, or you can even say 1 over 25. And 5 to the negative 3 power is 1 over 5 to the third power, or 1 over 5 times 5 times 5. So every time you divide by another 5, you're going to put more 5s in the denominator. So basically, if I have a negative exponent, I'm going to end up with a reciprocal. So the negative exponent just flips, to use a really crude way of saying it, just flips the number, right? If I had 7 to the negative 2 power, that's going to be 1 over 7 squared. But if I already, because it's 7 over 1. But if I already have something like 2/3 to the negative 4th power, that's going to be 3/2 to the 4th power. Again, I'm using the reciprocal. All right, so let's do some examples. Two to the negative 3rd power is simply 1 over 2 to the 3rd power, the reciprocal. You could also write it like this, 1/2 to the 3rd power. Both of those would be equivalent ways of doing it, because the reciprocal of 2 is 1/2. Okay, and then the negative 3, the exponent becomes positive 3. To keep simplifying it, I would have 1/2 times 1/2 times 1/2, which is 1/8. Negative 3/4 to the negative 4th power, and I got to talk about the negative, so I'm gonna ignore that in just a second. But I gotta throw another problem in to keep it simple. Do the reciprocal, 4 over 3. Now, instead of negative 4, it's to the 4th power. The negative is still there. I just hid it, but it's still there. let's see, 4 times 4 times 4 times 4 is 256. And 3 times 3 times 3 times 3 is 81. And I've still got the negative there. So I get negative 256 over 81. You can leave it like that. Excuse me. I just want to mention one thing about the negatives, whether it's outside the parentheses like this problem or inside the parentheses. I keep forgetting that I have to go back and explain all these things because usually someone would ask. I have to predict that you're asking this. Just remember, I'll make it simple. Negative 5 to the second power equals negative 25. But negative 5 to the second power written with the negative inside is equal to positive 25. Why? If the negative is inside, that means negative 5 times negative 5. A negative times negative is a positive. If the negative is outside, that means the opposite of 5 to the second power, which is the opposite of 25, or negative 25. So again, all of this is Algebra 1 skills, the language of algebra, so that we can go forth and make sure that we understand how to do the problems we're going to be seeing in Algebra 2. All right, reciprocal, 3 over 1 to the second power. That's just 3 squared, which equals 9. I know, I did that one kind of fast. And this one is, excuse me, still dry throat, 1 over negative 5 to the 5th power. So I find the reciprocal of negative 5, and then I change the negative 5 in the exponent to positive 5. Excuse me. Let's see. Oh, 5 to the 5th power is 3,125. So this is 1 over negative 3,125. Okay, in the next video, I'm going to be doing more problems like this.